So the legend has it that this man here, Rene Descartes, was laying in bed one night and he observed a spider or some kind of insect walking across his ceiling, and it just dawned on him that he could define points in the plane by their distances vertically and horizontally from a given point. And from there was born our system of coordinate geometry, which is a huge aid in connecting algebra and geometry to us. So, two metrics that are pretty important in the coordinate plane are the ideas of midpoint between 2 points, halfway point, and the distance between 2 points. So let's take a look at those here with a specific example, and then we'll derive formulas for the general examples. So point A here has coordinates 2, 1 because it is 2 horizontal units from the origin and 1 vertical unit from the origin. And point B here has coordinates -3, -2. All right, let's start with the midpoint. So I'm going to go ahead and connect these 2 points with a line, and we're trying to find the halfway point between points A and points B. That amounts to basically averaging the x coordinates and averaging the y coordinates. And we've done lots of activities with averages in our past, so we know that to take an average, all we have to do is add and divide by the number. In this case, there are 2 objects being averaged, so divide by 2. And so for the y's, we'll do the same thing. Add them together and divide by 2. So what does that give us? That gives us -1/2, and it gives us -1/2. Oh, interesting. So let's see. That's roughly right here, and based on the picture, that looks reasonable. So midpoint. Now, distance. How far is it from point A to point B? Well, I'm going to go ahead and draw in a extra point here in the diagram. This point has the same x-coordinate as point A, so that's 2, and the same y-coordinate as point B, which is -2. Using those 3 points, I'm going to make a right triangle. And I'm making a right triangle because I know certain things about right triangles. I know that their 3 sides have a special relationship, and we'll come back to that in a second. First, I need to know, since I'm looking for, I'll call this D for distance from point A to point B, I need to know how long the other 2 sides of this triangle are. Okay? So, how far is it from point A down to this point right here? They have the same x-coordinate, so all this amounts to is subtracting the y-coordinates and taking the absolute value. Okay, so this side has length, absolute value of 1 minus -2. And I'm going to put the absolute value bar there because in general I don't know necessarily which coordinate is going to be bigger. In this case, it's clear that 1 is the bigger coordinate, but we need to make sure we come out with a positive answer. So that distance is 3. This distance from point B to this extra dot, these 2 dots have the same y value, so I just have to count horizontal units, so I got to subtract the x values. So I'll do the absolute value of -3 minus 2. That'll guarantee me that this is a positive number, and we get 5. So now I have a right triangle that has sides 3, 5, and mystery. So we can use the Pythagorean theorem to find the third side. 5 squared plus 3 squared equals d squared. So we have 25 plus 9 is 34 is equal to d squared, and so d would be the positive and negative square roots of 34, but because we're talking about distance, we'll reject the negative and just use the positive. Let's take this principle just to general coordinates, general points in the plane. So let's label point A as having coordinates x1, y1, and let's label B as having coordinates x2, y2. And they could be anywhere. They don't have to be in these locations. That's just where we have them located. So I'm going to make no assumptions when I make general relationships between quantities here. So first, let's talk about midpoint. Midpoint amounts to finding halfway point between 2 points, which amounts to averaging x coordinates and averaging y coordinates. So the midpoint between these 2 points would be x1 plus x2 divided by 2. Once again, comma y1 plus y2 divided by 2. So that's your general midpoint formula. To find distance, we're going to apply the same principle we did on the last slide, which is to make a right triangle. But first we need that third point, and that third point is going to have coordinates x1, same x coordinate as point A, and the same y coordinate as point B, which is y2. Okay, let's complete the triangle. Okay, the distance from point A, let's call this point C. The distance from point A to point C is the difference of the y values. I'm going to take the absolute value to guarantee that I don't do it backwards and get a negative by mistake. So the absolute value of y1 minus y2, and the distance from point B to point C is going to be the absolute value of the difference of the x values. So I'll say x2 minus x1. This is my mystery side. I don't know how long that is. And so we can use the Pythagorean theorem now on that triangle, okay, which says that d squared is equal to the absolute value of x2 minus x1 squared, and I'll go ahead and write that for the moment, and we'll adjust it in a second, plus the absolute value of y1 minus y2 squared. When you square something, it automatically comes out positive or 0, so I can drop the absolute value bars, and that's why you don't see them in the final formula. Okay. It also does not matter which order, okay, I wrote the coordinates, whether it's x2 minus x1 or x1 minus x2, because we're squaring. So I'll go ahead and write the second quantity as y2 minus y1, just for consistency. And again, we take the positive square root of both sides, but we reject the negative on the other side. So we will finish with the distance formula for us, which we'll use quite a bit, is x2 minus x1 squared plus y2 minus y1 squared. And from time to time, just for symbolic purposes, it might be more convenient to write square root of delta x, which means change in x squared, plus delta y squared. In these two tables, I have two sets of x and y coordinates, and the directions here are to calculate the change in y divided by the change in x for each consecutive pair. So delta y divided by delta x, which from the last slide was seen to be y2 minus y1 divided by x2 minus x1. If you'd like to do that, pause the video and go ahead, but I'm going to go ahead and move on. The first set of pairs, when we find these delta y's over delta x's, comes out to be looking like this. Okay, 2.1, 2.35, 6.85, and 3.15. Numbers all over the place. However, when we look at the second set of coordinates, it turns out that their delta y over delta x always came out to be the same number, 2. This second set of xy coordinates is a special relationship between x and y. It's called a linear relationship. So what is a linear relationship? Any relationship where the change in y divided by the change in x is constant, which means it doesn't change no matter what 2 points we choose to use. Now, you may have guessed correctly that the graph of a linear relationship will come out to be a line, and that's correct. On this slide, we want to talk about how do you write the equation of a line if I give you a point on the line and the slope. So let's say we gave you the point 2, 1 and told you that was on the line, and we told you that the slope of the line was 2/3. Okay, and the slope of the line is the same thing as the change in y divided by the change in x. That's what slope means. Delta y over delta x. Okay, so here's what we know. We know that no matter what 2 points we choose on the line, the change in y divided by the change in x has to be 2/3. Now, they only gave me 1 point on the line, the point 2, 1. So, I have to come up with a second point, and so let's use the point, the general point, x, y, and this will create the relationship between x and y that we're looking for. So, the change in y here would be y minus 1, and the change in x would be x minus 2. From there, we just need to solve the equation for y. So we can multiply both sides by x minus 2, which would give us 2/3 x minus 2 equals y minus 1. And then we can add 1 to both sides, and we'll end up with y equals 1 plus 2/3 x minus 2. Okay, this clearly shows me the slope of the line is 2/3 as the coefficient of the x. And if I plug in a 2 for x, this first part vanishes, and I'm left with 1, and it shows me that 2, 1 is a point. In general, if I'm given x1, y1 is on the line, and I'm given the slope is m, then I'll do the same exact thing. Okay, I would say that m would be equal to the change in y. So let's say general y minus this specific y divided by general x minus my specific x. Multiply both sides by x minus x1, and then add y1 to both sides. And so this is the general form for writing the equation of a line that you're going to use most of this year. y1 plus the slope of the line times x minus the x coordinate that you were given. Two types of special lines we're going to encounter. So let's go ahead and find the equation of the line that goes through 3, 4, and 7, 4. So they did not give me the slope. I need to go searching for it. So let's go ahead and get the slope. The slope is going to be change in y's, 4 minus 4, divided by the change in x's, 7 minus 3. And this comes out to be 0. So the equation of this line is going to be y equals, I'll use 7, 4 as my point, okay, 4 plus 0 times x minus 7. This obviously wipes out, and so I'm left with y equals 4. Okay, and that leaves us with the fact over here that a horizontal line will always have equation y equals the y coordinate of the point they gave you. So if we give you a point and say you have a horizontal line, it's always going to be y equals. There is no x, because x can be anything. The y will always be 4. Okay, let's do the same thing for the line that goes through these 2 points here. Okay, they did not give us the slopes. Let's go find it. The slope here is going to be 3 minus -1 divided by 6 minus 6, which gives us 4 divided by 0. Now that's a problem, okay? This is undefined. So this line has a undefined slope, which is going to make it hard to write the equation of this line because it's supposed to be y equals y1 plus the slope. So what do? Well, we notice that 6, -1, and 6, 3 are on this line, and so is 6, 0, and so is 6, 1, and so is 6, 2. So every x value is 6. Doesn't matter what the y value is. And so the most logical way to write the equation of this line is just to call it x equals 6. Okay, special line. So a vertical line through a comma b has equation x equals a. All right, last line to talk about. You may know this already, you probably do. Parallel lines have the same slope. So here in red is y equals 2x plus 1, line with a slope of 2. And the blue line is y equals 2x minus 1, a slope of 2 also in blue. These lines appear parallel, they don't cross. And then perpendicular lines have slopes that multiply to be -1. So y equals 2x plus 1 is the red line, y equals -1/2 x plus 1 is the blue line. If you multiplied 2 and -1/2, which are the slopes, they come out to be -1. And perhaps if I rotate this a little bit, you'll believe that these lines are in fact perpendicular to each other.